Hey guys, welcome back. For today's video tutorial, I'm gonna have a look over a new sensor that is ITG-3200. Now, we have done a lot of sensors in our previous videos, so I'm gonna introduce to a new digital sensor that is ITG-3200. To gain more knowledge about this sensor, let's have a look over the website controleverything.com and now here search for this particular sensor and let's see what we got here. We got that ITG-3200 is a 16-bit 3-axis MEMS gyro angular rate sensor. So it's a gyrometer in short term, and what we can say about the features as you can see on my screen. Now you can also purchase this sensor from this very site, and I will be moving forward with a lot of options regarding this sensor. Today I will be interfacing the sensor ITG-3200 with a Raspberry Pi and a Java code. For that, let's have a look over the resource tab, and here we have the required Java code. Now, we have the opportunity to download this Java code as a zip file from this website. And also, we have the chance to download the code from the github.com, and we have a repository there that is called Control Everything Community. We can download this from there also. Now, what do we do is to collect some hardware we require for this particular video tutorial and connect all connections we require. Let's have a look over that. This here is our sensor that is ITG-3200, and now this is a Raspberry Pi, and these are the GPR pins which you are able to see on my screen. Now, how do we connect a sensor, a Raspberry Pi and a lot of other I2C devices and make this connection a lot easier to follow up? So the answer is this I2C shield. Now this is available on the website controleverything.com, and gently place this shield over the GPR pins of our Raspberry Pi. Now, what do we need to connect the sensor and the I2C shield? And here comes the connecting cable. Make this connection among the sensor and the cable, and while making this connection, one thing has to be sure that the brown wire of the cable should be connected to the ground terminal of the sensor. Similarly, for the I2C shield, this has to be followed strictly, and it's highly recommended. Now, we need to power up our Raspberry Pi, and here comes a micro USB cable into the picture. Gently put it over the power jack. Now we need to connect our Raspberry Pi and the sensor with an internet connection. There are two ways to do it. First of all, we need an Ethernet cable, and gently place it over the Ethernet jack. In case if you don't have the cable, you can also use an adapter, nano adapter Wi-Fi module. Now this is very useful and it can save you time. Now we are done with the connections part. What we require is our code so that we can have a look over it, explanation, interfacing, and see how it works with our sensor. Let's have a look over that. Now comes the interfacing of the sensor with the Java code, and for that log in and open up the github.com link. Now here type in and search for Control Everything Community, which is the official repository of controleverything.com. Now here search for the sensor that is ITG-3200, and here comes the sensor. Now this is the required Java code. Let's have a look over the instruction for the Java. That we have to download and install Pi4j library on the Raspberry Pi first. So this is the link pi4j.com, and let's have a closer look, and this will clarify all our doubts how to install and the instructions being provided here. These are the commands as you can see on my screen. Now do it carefully. Well, this is the command to compile the code, and this is the command to compile and run the Java program after compilation. So this is how the code works. Now get back to the code as you can see, and it's a .java extension file. First of all, we have imported some of the libraries which include some of the functionalities might be used in the code later on, and created a public class named ITG-3200, and we have the device address or sensor address that is 0x68. In the writing part, first of all, we have power up and set X gyro reference, and the command for that is 0x3E, 0x01 is the command. Now we have full scale range of plus minus 2000 degrees per second, and the command for that is provided here as you can see on my screen. After that, there is a sleep function which helps us to settle down and make the sensor realize what are the commands being provided here. After that, we have the reading part. We have read 6 bytes of data from the address 0x1d, and the values are being stored. After that, these values are being converted in the form of X, Y and Z axis for the gyroscope, and this is all according to the data sheet and the details being provided in the ITG-3200. Well, now we are done with the calculations part. What we require is to print out and display the results we have achieved. So I have rightly formatted the details for the raw values in the percentage %D, as you can see, and we have X, Y and Z axis of rotation here on the monitor. So this is how a code looks like this, and let's see how it works, which is an interesting part in itself. Now, as you see, we have came to the interesting part of this video, that is the practicality and to check whether this code works or not. So for that, copy this entire code and let's see the terminal for the Raspberry Pi here. Create a new file, ITG-3200.jar, and here we go, paste the entire code and save the file, and this is the command to compile the code, as you can see on my screen. And here we go. It sometimes takes a while to compile. It's done. Good to know that it's done early. Now command to run. Now we can have the data for X, Y and Z axis for the rotation. Again we have the data. Now when I try to rotate it, there will be a lot of changes for all three axes, and again when I'm trying to rotate it in the all directions, there will be a gyroscopic rotation in X, Y and Z axis, which is exactly in the dBs, degree per second. So this is how a code works, a Java code works for the sensor. Now let's have a look over the benefit, features and the reason why we use this code, this sensor, a lot of applications. So till now we have seen the explanation of the code working and connections part of this particular sensor. So the ITG-3200 is the world's first single chip digital output 3-axis MEMS gyro IC optimized for gaming, 3D mice and 3D remote control applications. The part features enhanced bias and sensitivity, temperature stability, reducing the need for user calibrations. Low frequency noise is lower than previous generation device, simplifying application development and making for more responsive remote controls. Due to these wide features, it's applicable in a lot of applications like motion-enabled game controllers, motion-based portable gaming, 3D mice and 3D remote controls, no-touch UI, health and sports monitoring, and a lot more. This sensor can be purchased from the website controleverything.com, and you can get the code from the resource tab, and from there you can download it. You can also get the code from GitHub repository, that is Control Everything Community. So as we are done with all the requirements for this particular sensor ITG-3200, I just would like to make it clear that in case if you are in a kind of thought that you are not able to understand any part of this video, any section, you can put your queries on the controleverything.com and put your comments on the community page of this particular website. Now for blogs and articles which are relevant to this video, you can blog or post me on instructables.com, and also if you have interested or want more video tutorials like this, you can subscribe our YouTube channel. So I hope you enjoyed this video and have yourself a good one. Thanks a lot for watching.